Good afternoon, everybody. Hello from Russia. Well, my name is Vitaliy Kamlyuk, and I'm a senior virus analyst. I work at Kaspersky Lab. Well, what I do is deal with viruses and hacker attacks. So my presentation is going to be kind of entertaining. I hope so. And I'm going to show you some quite advanced techniques of working in the Windows system that can help you to fight malware on your own. So let's begin. Well, these are 5 reasons of why do you need to know how to fight malware on your own. That might be reasons for users, like, users can touch 100% of protection themselves if they use antivirus solutions, and it protects them for 99%, and 1% they can add themselves by using their own knowledge, and they can be prepared for attacks. Well, they don't need to maybe download the freshest software because they are prepared for attacks, and they can fight with the attacks and with viruses on their own. Also, they maintain confidentiality, so they do not need to send their very important files, which can contain some personal information, to any virus labs for analysis. And the very important thing is the ability to restore your system here and now. When you don't have any other third-party tools, you can restore your system using just only Windows tools. And that's what I'm going to talk about. How to restore your system, how to fight malware using only Windows. No third-party tools, and imagine that you don't have any internet connection, so you cannot download anything. All you have is your, pure Windows system and nothing else. Well, and sometimes time really matters. And if you do not react immediately, you can lose your system, lose your data. And time is very, very, very important. So, I don't want to, say a lot, to tell a lot of abstract things. I want to show you several examples. Well, let's see what's available on Windows XP. Well, it's system tools like Explorer that you all know, Task Manager, Register Editor, and Signature Verifier. We have also some console utils like netstat, task list, reg util, and expand. We have interpreters like Batch Interpreter or JavaScript with Visual Basic script. Well, there are some text editors like Notepad, WordPad, Edit, and AddLin that came from DOS times. Well, the only binary editing tool available on Windows currently is debug exec tool. That is not the specialized tool for editing binary files, but that's the only way how you can create, how you can view and create binary files. Well, that's kind of dirty hack on Windows, but still this tool works and it is part of Windows. Well, I'll talk about it a little bit later, because Microsoft decided to remove this tool from Windows Vista. Well, also you have symbolic debugger, NT-symbolic debugger. It is a part of operating system starting from the NT 4.0. And you have all the repositories that you can use. Let's go further. Let's see an example. Well, the example is email worm Win32 Verezov. This is an email worm that was detected last year, and it is quite, kind of very fast mutating worm that produced more than 400 of modifications, which is more than 25,000 of files. So for 1 year, we have received this number of files. Well, we suspect that it mutates on the server side, so there is no mechanism in the worm that allows the worm to mutate itself. And it downloads additional modules from the internet and hides itself from Task Manager. Let's see how the usual user can infect his system. Well, he just needs to open a file that looks like a text message. Well, by clicking it, of course it is application. We just don't see the extension, and usual user doesn't also. Well, what he sees in the open file is kind of trash. That makes no sense. But if you will be attentive, you will look at the title of this window. It is 2TMP. And we opened slightly different file. And this file, 2TMP, is created in the same directory. It's kind of an anomalous activity. So the attentive user will try to maybe download some antivirus solutions. For example, here it is KAV, which is Kaspersky antivirus. Well, if you even try to do that, he will see the following picture. He clicks on the application shortcut, but nothing happens. Well, the user might think that there may be a error or mistake, some kind of bug in the installation package, or maybe his system doesn't satisfy the system requirements. But let's see at the other side of Windows. By the way, is there any Microsoft employees in this room? Please raise your hands. Come on. No Microsoft employees, good. Because I'm going to show you the backstage of Windows. Okay, let's do that. What happens when user clicks the shortcut? Well, all the messages, everything is processed by Explorer exe process. And it constantly executes some code, handling input messages coming from mouse and keyboard. Well, what Explorer exe does is preparing a new application for launching. It prepares the environment, sets all the necessary settings, and then launches calls the shell execute X function to create a new instance of process. So here it goes. This is the installation process. The first thing the system does is loading necessary libraries into the address space of the process. And among those libraries, there is a malicious one that first decrypts strings in it. And here we go. Here we got string KAV, which corresponds to Kaspersky antivirus. And if it checks that it has been in the address space of KAV process, it just calls exit process function to terminate the application. So this is what is happening on the user system. Okay, what can we do with it? How to help user to install the antivirus? Well, we have to inspect what happened. The first thing we should do is carefully check the access date and time of the source malicious file. We will need this information a little bit later. After that, we have to find all the files that were created or accessed today. So we check that we select searching for all files by date, specify the access date, set it for today, and check the option to search hidden files and folders. It is necessary. I think you understand why. So when we get the list, it's kind of very, very long list. And the first thing we should do is to sort it by creation date. And after this, we can see the list of files created after opening the source malicious application. And here are the files. You can see this original message file and some more files like surf.exe, which copied itself to C Windows folder. And it is also an application, and it has the same size as the source one. and is placed in system folder. So it can show us that we launched the Trojan application, or malicious one. The first thing we can try to do is to delete this application from Windows system, so from Windows folder. But we got access denied message. So this file is locked by some other application, or maybe it is just running on our system. If you check the list of processes in Windows Task Manager, we cannot find this process. What does it mean? That may be the reason, that may be caused by active rootkit present on our system, or just by locking by another process. So if we get the alternative list of the processes, we can see that surfexe is running, but we couldn't find it in Task Manager. So it got to be a rootkit working on our system. Well, to terminate the process, we can use the task queue command, which is also a part of Windows XP system. Not many people knows about it. I don't know why. Well, we terminate the process, and after that we can try to delete. We can try deleting additional files coming with this Trojan. E1 DLL. We try to delete it and get the same message, access denied. So the DLL is locked by some other process, or it can be loaded into the address space of the process. Let's try to check it. We use the same command task list, specify the particular options for getting the list of the processes, which loaded E1 DLL, and here's the list. You can see here, among the other DLLs, E1 DLL. It is already loaded in our task list exe that we use for getting this information. So it must be loaded into every process that is starting in our system. So to find out how this malicious file do this, of course we should check the registry. We open the registry editor and try to find this E1 DLL string. And here it goes. The key is ASCII local machine software, Microsoft Windows NT current version Windows app init DLLs. This key is used by operating system when a new instance of the process is created, and the system loads all the DLLs listed in this parameter into address space of the process being created. Okay, I guess all of you must know how to fight this malicious application right now. Well, please raise your hands who knows what to do in order to remove this application, in order to remove the library and executable. Please raise your hands. Okay, very few. I showed everything for this. Okay, let's see. Well, it's very easy, really. Well, all we have to do is just to prevent this E1 DLL from being loaded into every process. So to do that, we just need to open registry editor again and modify registry settings. Nothing more. So we just open this key and remove the value. We also need to check where the surfexe, where it changed the registry values in order to start after a system reboot. So we have to search the registry for this surfexe value and to remove it as well. After that, we can easily reboot our system and check if the malicious application is still present. It's that easy. I guess everyone is present here will find this way himself when he will met this malicious application on his system. Well, when we reboot the system, to check if everything is okay, we can just try to run the antivirus installation again. And here it goes. Everything seems to be okay. So after that, we can automate removal of malicious files using antivirus, or just delete the files ourselves. Well, we have published this information on our site, which is www.viruslist.com. And these instructions were published for users who cannot install the antivirus solution. So the malware creator read this message as well, and he saw that it is too easy for user to to stop his malware on his system. So he tried to create a kind of resistance to manual removal. Let's see how it works. So when the user deletes the value from the registry and reboots his system, he's trying to run the antivirus solution. And he gets nothing. Seems like the malicious application continues to work on his system. Well, let's check first the list of the processes. With the task list command, we can do that easily, and we do not find surfexe process. But E1DLL might be still working in the address space of each process started in the system. Let's check the registry. Yeah, you got it. Up init DLL's value contains E1DLL. We try to delete it and check it again. Open the registry editor, and what we see, the value is returned. So let's try to analyze what happened. And what can we do? The first thing we notice that malware restores the register values when the application terminates. When the E1DLL is maybe unloaded from the regedit process. And there are a set of the processes running and closing from time to time on our system. But the routine that restores the value is called several times. But the value is restored only once if it is not present in that key. So it looks like the malware uses one of the following functions that are used for searching substring in the specified string. So what can we do with this information? We can hack the malware removal resistance mechanism. Please, those of you who know how to hack it based on this information, please raise your hands. Okay, not very many. Then let's see how to do that. It is very easy. It is based on the the way malware checks for the value. It checks for presence of substring in this text. And what we have to do is to add some trash to this string. Well, when the malware calls this function of searching for substring, the function returns true. Yes, this E1DLL is really present in this value. But when the system is trying to load this module, it couldn't find this module. It can't find this module, and nothing is loaded. So we can easily, after that, reboot our system and, delete the malicious files. Okay, let's talk about the other example, which is Trojan Win32 agent ACH, which was made in Japan, and it was detected on December of 2006. Well, after running, it silently removes itself, and it suspends its destructive functionality till the next Friday. After that, it disables pressing Ctrl-Alt-Delete, disables running an executable file from shell, disables system shutdown and reboot functions, and if you try to hard reboot, it disables loading your system in any available mode. So let's see how it works. Well, the infecting of the system is quite obvious. As usual, you see the file in a mail attachment, or just found it in the network. You launch the application, it disappears. Of course, it looks like a Trojan activity, so you have to be very attentive. And when you see such kind of things, please check everything. Well, how infection symptoms look like? Well, we are trying to launch our favorite applications. Maybe Outlook Express doesn't run, Windows Media Player doesn't run, Remote Assistance doesn't run. When we try to launch Notepad using Start Run menu, nothing happens. The same with Registry Editor. Well, this is the case when time really matters. Because if you try to postpone the queuing routines, queuing procedures, you will lose your system. So you have to do something immediately. If you reboot your system, you will lose it. That is the result of hard reset. You will get this picture on your screen, and nothing will boot. No safe mode, no any other way. So all you can do is just using some, maybe live CDs if you got one. But if you have only Windows system and nothing else, you can't do anything. So you have to do the queuing, to apply queuing procedures immediately. Let's see what we can do. Let's inspect our system. Well, Task Manager is still available, despite of the other applications cannot be run. We can see the alien processes in the process list. Well, my computer Explorer is still available, and we can run Internet Explorer. Well, but one more thing, find files is working. So the first thing we must do is just to find the alien files on our system. And here they are, in Windows System 32 folder, as usual for Trojans and malicious applications. So we have found both files, but we must access the registry editor to find what has happened. It disallows us running registry editor in usual way, so we will use a kind of unusual one. We will use Internet Explorer for launching a new process. Here is a little simple script written in JavaScript for launching a new process from the address bar of Internet Explorer. It is very easy. It creates ActiveX object of wscript.shell and calls one of its functions, which is exec function. Here we go. We launched the registry editor. Now we must search for the files, the name of the files that we have found. And here they are. The path is hashkey classes root exe file shell open command. If we open the neighboring value, which is run as command, we see that it is not modified. So it tells us that we still can launch any process on our system, but in an alternative way, not using open, but using run as, specifying the current user and the application will launch. Then we must find the second file executable, and we find it in the hashkey local machine software Microsoft Windows NT current version WinWagon UI host value, which is used by operating system when you boot your system. So this malware modify this value, and when you reboot the system uses this value to launch this process. And if the process belongs to a system one, it will continue booting your system. But in this case, it will the booting of system will be stopped, will be prevented. So that's the way how this Trojan works. Well, how to remove it? It's very easy, I guess, when you got all this information, when you did the inspecting. Okay, we just need to run the registry editor using this way that I showed before. We run it, and we must just restore all the values that were modified, that we have found. Well, I think that we will not pay so much attention to it because it's quite obvious. We just need to restore the original values, which are not that complicated, and you might know all of them. So let's go further. Control check is already, it's obvious file. It really works. We will skip it because of lack of time. Well, virus Win32 Suburix A. This is a place in my presentation where I must wear this cap. Crazy. It is written here. So here is the most interesting part of my presentation. Here it starts. Well, it is an executable virus, Suburix. It was detected last year, and the virus infects executables files located on hard disk partition, which is selected at random. So it infects random files. It injects on the well into every process that has visible window. It makes screenshots of running of opened windows, and it sends them to the internet. So this is all about this virus. Let's see what we can do in order to cure the executable virus on our own from scratch. The first thing we must do is to get the code of the virus. To do that, we must use NTSDU2. Let us assume that we have this infected application. It is Kodak image exe, which is part of Windows. Well, it is infected. We know that. Let us get the code of the virus from this application. We use the NTSD tool, which is part of Windows, to get the assembly code of the application. The first thing we must do is to view the IP header. We must specify the base address of the application. Check the address of entry point, and after that, unassemble a piece of code starting from entry point. Usually viruses put their code right there. The same is with Suburix virus. And here is the assembly listing. But we have these, instead of names of API functions, we get only the offsets of addresses of these functions. In order to get more or less readable code, we must patch it and put the names of the API functions. So I will show you how to do that. We use the address, which is used for call operation, and we can check what is placed at that address. And this is get module file name A API function. After that, we apply a small patch to the place where this function is called. And that's all. Print the unassembled listing. And we can see here that we have now this get module file name A name. Well, it's quite readable. The same can be done with other calls. But after all, we get the code listing. It's not that large, as you see it. Only maybe five screens, right? And this is all the code that you need for analysis. After analyzing the code, you can understand, you can see the clear picture of what this virus does. Sorry for my English. Well, by analyzing the source code, we can reveal the following picture. Well, the virus uses the source file. It cuts the header of source file, compresses it, and stores at the end of the file. It replaces the header of source file with its own header and with its own virus section, which contains executable code. Also, it attaches a compressed virus module in the end of the file. So in order to cure the infected file, we have to remove all these pieces of code and pieces of data which were added by the virus. But after that is the most difficult thing. We have to decompress the chunk of source file and put it in the beginning. Well, in the case of Suburix, we are quite lucky because it uses the algorithm of packing cap files. And Microsoft operating system includes the tool for decompressing these cap files that we will use. But to create the solution, our own small tiny antivirus for curing these files, we have to build our own PE application, PE file. Well, it will be quite obvious. It will contain only PE header and one section. Well, in the section, there should be placed import directory table, import lookup table, and import address table. This is obligatory. Well, also there must be import names, which are the names of API functions that we will use. There will be some piece of user data and user code, which we will create right now. Okay, let's see how it looks like. Programming the pure machine code in Notepad. First we have to do is to plan our actions. Here is a short plan. Zero field work area, create import list, create import tables, prepare space for our variables, create user code, relocate user code, create PE header, and write to file. That's all. That's easy, right? Well, the second thing we must just put as notes in Notepad is the map of the memory that we use for our solution. In order not to get, messed in all of these memory addresses, we have to mark every space that we use. Something is for PE header, some for work area, the space for import address tables, and so on. Some space for user variables, and of course for the code. Well, let's start. Let the show begin. This is a scenario actually for debug exe tool, which is part of Windows system, I repeat. So this is the coding in hex. We just build the import tables. We set our variables, the initial values. And here go the user code. This is machine code in hex. Well, it's not that difficult really, and I coded it myself in Notepad. And all you have to remember is maybe a dozen of opcodes, like conditional jumps, the calls of the functions, and pushing parameters and popping them from the stack. And if you even forgot the opcode, you can always use this NTSD tool to assemble or disassemble the code. So you can get the opcodes just remembering how they sound in assembler. I used not more than 10 different opcodes here in this code. So what we do is open the file, cut and remove the infected parts, and extract that part that was compressed by the virus. Okay, let's save now this file. But before, we have to remove our comments. They were just useful for creation of this file. We save it as a text file. And after that, the magic scene, converting the text file to executable. We just call debug, redirecting the input from this text file. And that's all. We got some errors here because of our comments, but it doesn't matter because the file is created. It is actually a .bin file. You see cure.bin here. 3 kilobytes size. This is the smallest antivirus solution I have ever seen. After that, we rename this bin file to exec and execute it. Oh, not really execute it because it doesn't contain the decompressing routine. So we now have to build another file for calling this decompression routine? Well, we have to build one more file, which is batch file. What we do here is copy our source file that was infected to file.in, call our current solution to remove the infected parts of the file and to extract compressed one. If we extract compressed one, there will be a file tmp part1.cap. If it is not found in this directory, that means that the original file was not infected. So we have a check here in order not to cure not infected file. So if the file is extracted, we just call the expand util that extracts this cap file into a temporary bin file, which will be used further. After that, we glue two parts of the file and get the clean executable. Okay, let's save it and run. Here we go. Here are our files. We just run the batch file and execution stops. Here it is. We got codec image exe.clean, which differs from the original infected files by 30 kilobytes. So the infected part took 30 kilobytes, and this application, this new file, is clean and ready to run. Let's check it. Well, it runs okay, but wow. Sorry, it runs okay. It just requires some additional DLLs while being run. So it just output this message box. Well, let's see at system evolution of Microsoft operating systems. Well, as for Microsoft systems, Microsoft included more and more utilities in their newer operating systems, maybe for compatibility issues. But as for Vista, here we got different picture, because several very useful utils for such kind of hacks maybe were removed. Such util as NTSD and debug.exe were removed from Windows Vista. And the number of useful utilities in Windows Vista is lower than in Windows XP. And as for Unix, it was always based on tools, and there is a great number of tools that can be used for creating your custom solution. So as for Vista, we had a set picture here. But what can be done on Vista? Vista includes Microsoft.NET as a part of operating system. And this technology can be used for our needs. Well, the problem with with Microsoft.NET is documentation. It is not included into operating system as an opposite to man pages in Unix. So we have to do something, and what we can do is use this .NET reflection mechanism. It allows us to browse the classes, to browse the libraries, and to see the members of the classes. And it is everything what we need. What, for example, I need for creating any application on .NET. So we build this txt file, and we call compiler of C#, which is part of Windows Vista. And after that, we call our application specifying the necessary class that we're interested in. So we can browse the framework. Here it is, system.io.file. Here are the file functions. The members of class that is devoted to working with files. And we can see not only the names of the methods, but the parameters and the types and the return types of functions. And this is enough for creating any custom application without documentation. Well, let me show you examples of using this .NET for creating some custom solutions from scratch. Well, it is very interesting to sniff malware communication. Well, the obvious thing we can do is to analyze what Windows Network Monitor says. It is a part of Task Manager. And it is not enough. We sometimes need to catch DNS requests, catch HTTP requests, and even implement our own IP packet filter because it is not included in Windows. It is very useful to trace downloaders or vectors that are used for creating zombie networks. Well, let's see what we can find looking at the Trojan downloader. Let us assume that we have a Trojan downloader application running, which is called malware.exe. We know that it tries to download something, but we do not know what exactly and what server it uses. Let us assume that we have located the file. And now, let's try to see what can we do with network communication. Well, I used Microsoft Loopback adapter here. If the network is unavailable, you can use this adapter for your network experiments. So what we do is set DNS server IP address to our local host IP address. After that, we have to build a kind of listener on our local system, which will listen for any connections to the port 53, which is DNS service port, and will output all the data coming to this port. Here is it. One screen length. This is it. We create IP endpoint on port 53. We open the socket, listen to new packets in the loop, and output every incoming data. That's it. Easy, right? You can do that, right? Well, let's compile our source. To do that, we must specify in path environment variable the correct path to the framework binaries. So we do that with a set command. After that, we run the compiler. Got some errors. It's okay. Run it again. Okay, here is it. DNS sniffer.exe. This sniffs for any incoming DNS request and prints to the console. Here we go. Malware tries to send DNS requests. It tries to find VPAD host, which is used for web proxy auto detection. After that, it tries to connect to the target server, which is www.woodpoundco.com. Here is it. We got the address of the server which the malware is trying to connect to. What we need now is to look into the requests which this malware will send after finding the server. And to do that, we must fool malware again. We open the hosts file and add a new string there. We specify our local IP address and this name of the server which malware is trying to connect to. So when the malware will try to find the server, our system will put our local IP address. So the DNS request will be not used because we have a record in our hosts file. So the malware will try to connect to this web server, and now we have to build this web sniffing solution that will open on our local host the port of 80 and will print all the requests. We do the same, just compile this application and run it. By the way, before running, we must terminate the downloader if it has any delays in it. So we must rerun it. We start our web sniffer, run the malware, and wait for a while. First, it tries to resolve WPAD host name, and after that, it connects to our server. Here is the request: get LDR index PHP blah blah blah. And one more useful thing: it uses Microsoft Bits service. It is servers, a part of operating system, and it uses it for downloading files from internet. So we get a scenario and the address of the files, address of the server, which are used for downloading malware. But it is not enough, because just imagine if the malware doesn't use DNS at all. It has, for example, hard-coded IP addresses in the source, and it doesn't try to search for any names. So we must use, in this case, total IP packet filtering. Well, we will fly for a while. This is how operation system can be imagined. The columns are the processes. Here are the familiar names: SVC host, services exe, and any other. And we get malware exe running in our system. Well, every process consists of modules, and they can use any communication interfaces in our system. Well, the process consists of executable file, which are marked with white color, and with blue color are marked DLLs, which are used by the process. This is how operating system can look from inside. Well, every process is based on system libraries, which are kernel 32 DLL. It can be user 32 DLL and advp 32 DLL, which are parts of operating system. And kernel 32, you know, it's kernel module. It's a kernel of operation system. Well, and when the malware is trying to connect somewhere, it generates IP packet, which will be sent to the network. So the usual way, it generates packet and sends to the WAN, trying to reach the destination. But what we are interested in is the content of this IP packet. So to get the content, we must filter all packets that are going out from our system. And we must build our own process that will help with it. I called it APXA. It is a small application, very, very simple. This process will help us to do that. It will happen like this. When the malware generates new IP packet and sends it to the network, our application will build a packet filter and redirect the IP packet. This IP packet will come to our application and it will absorb it like bloop and analyze it. Let's see how it looks well, in our usual way in operation system. Well, let's check this example, backdoor Win32 IRC bot. This backdoor is used for creating zombie networks. So it's dangerous enough. So we must trace where it tries to connect to. And we create this source code for our application, APXA. Here is it, a text document, APTXT. And we also created a web.txt file. It is the same web sniffer. We will use it. So we check the network activity. It is 0 level, and after running malware exe, it is above 0. So something is happening on the network. So to trace it, We must compile our application, build and compile. It is 9 kilobyte size, as you see. Not that big, but not that small. Okay, let's compile. We compile the source code. Some error. We have to specify unsafe option because we call API functions directly. Well, after that, we run our application and wait for packets. Well, here they are. But in order to fool the malware, we must specify the gateway because the packets are sent to the gateway. The packets that are for any host that is out of our LAN. So we just specify the IP address of the gateway, the same as our local IP. And here we get a packet of our market right now. That is for host that is out of our LAN. And the port is AT, which is web server. So after that, we can use web server emulation and to listen to incoming packets, specify the IP address to the one that is needed for the malware, and sniff for requests. I will skip it because we have a lag of time. There are more interesting things. Some advanced techniques. How to view PE header, ways of terminating, alternative terminating process, and so on. To view a PE header, you need to use NTSD tool. Specify the path to the target file, locate image base after running this tool, and use DH command to print the header. Here how it looks like. Well, ways of terminating processes. We can use task manager, task list plus task queue that I have already showed. WMI technology. We can use Windows scripting host to create our JavaScript to get the list of the processes and to kill them. We can use VBEM test application, which is part of operating system, which helps to communicate with WMI interface directly. We can use NTSD to attach the debugger to a running process and to invoke kill function to terminate the process. We also can build a PSQ-like own utility in machine code using the same techniques that I already showed. But to get the speed of the process, we must use some other tools. We can also build our own PS list-like utility, but we can use existing solutions like QProcess, MSN432, and Performance Monitor. I will show you the most interesting ones. Task list plus task queue is obvious, we'll skip it. WMI plus WSH. This is actually a JavaScript small sources that can be used. Well, we create an application in JavaScript that contain only 2 lines, and it is enough for getting the list of the processes and to kill the specified process. So all the sources that are in this demonstration, this presentation, can be found on the CDs that you already got, I hope. They're in the folder with my presentation, so you can check everything on your systems. Okay, I will skip it because we don't have much time. Here's one more interesting way using WBEM test util. We just use start run WBEM test. Here we go. This is application which is a part of Windows XP and Windows. Yes, only Windows XP. It's not a part of Windows 2000. We connect to a repository and specify SQL-like request to find the necessary process. It is select all from Win32 process where name like. We want to terminate notepad application. Here we go. We got the list with only one item. Then we must copy the path of the object in this repository, and we will use it later. Copy. After that, we must execute method of this object. We click the button execute method, specify the object, just paste what we copied. Here we go. There is the object, and we call the method terminate. Execute the method, and the notepad disappears. This is it. Let's see, well, NTSD, I will skip it because it's quite obvious. We just need to attach to the running process and queue it. Well, our tool in machine code, we can implement it, and here is the source code. It's very, very small for queuing the process by its speed. But to get the speed, we must use some, external other tools, which are actually parts of operating system. There is a tool queueProcess which outputs the list of the processes with speeds. The second way is to use MSInfo32, the tool which can tell us a lot about our operating system, and we can find the list of the running processes in running tasks section. We can find our process, notepad exe. Here is PIT 2008. And the most interesting and tricky method is to use performance counter to get the PIT. Well, it's very unusual, even for me. That's why I call it crazy sometimes. Well, we run the performance monitor. Remove any existing counters. Come on, do it faster. I got a slow PC, sorry. We remove the counters and add a new one. Well, I don't know why, but Microsoft included a lot of different counters and different objects into performance monitor. They're, sometimes they're quite silly, like this one. The process with performance counter for process ID. Well, the process ID never changes during the running one application. We can find our application here, select the instance of the process notepad, and we get the constant value 2008. Very interesting. Well, sometimes applications are packed, and we can dump a process, any process on Windows system. To do that, we must use familiar tool NTSD. Well, I guess I don't have enough time to show all this. I will describe it just in words. What we have to do is open NTSD application, attach to a process, and try to dump all the data that is present now in the process memory. But unfortunately, NTSD application included in Windows XP is quite old, and it doesn't allow us to dump it directly. So we have to use the log feature of NTSD. We have to log all the output of NTSD and save it to a text file, and after that transform our text file into a binary using the batch and debug exe tool. That's the scenario. Here is one demonstration of packing the notepad exe with UPX and dumping it after that. Well, it works. If you want to check it, you can find this video file on a CD. Let's keep it and see what we got else. Well, very useful technique is extract string data from the binary. What we need to do is just grab all sequences of bytes from a given file that form a string consisting of 3 or more ASCII characters. Here is the JavaScript implementation of this technique. So we can build a simple JavaScript file like this and apply it to any binary. Here's a demonstration. Here's a Trojan Croton, which makes very significant changes to system registry and system policies. Look, we don't have, for example, file menu in this Internet Explorer window. Here is our start menu. We cannot run command prompt. It is disabled by our administrator. We cannot run, of course, registry editor. But what we can run is notepad. This is enough. We are kind of notepad hackers, right? Well, we open Notepad, and with the help of open file window, we can browse the file system. We can try to launch registry editor. Of course, it is disabled. But to enable it, we can use reg.exe tool. To do that, we must specify some parameters. And to be able to do that, we have to create a shortcut to regexe and specify these parameters. These parameters tell the system, tells the regexe file application to remove disable registry tools value from the registry. Well, we just run this shortcut, and this value is removed. After that, we can run registry editor. So after that, it is easy. You know, you can you can delete the values from the registry that you already know, that you are familiar to, some system policies. But if you do not know some changes that were applied to your system, you can find it out easily by viewing the strings of the source malware application. That is where you have to use this JScript file that I showed you before. So here is a demonstration of it that you can watch on your own on a CD. And we will skip it because we don't have time. So the results. Well, the ordinary user can touch 100% of protection, and he's ready to be attacked. You are ready, actually, to be attacked. You can preserve your confidentiality, and you can restore your system here and now. You know why time matters? Because you can lose your data if you postpone the procedures. Well, the questions can be asked in room 109 after my presentation. So may the force be with you. Thank you very much.